Adrian from Live to Learn Academy, and today we're going to be going through lesson 8.6, solving logarithmic equations. Now in 8.5, guys, we were solving exponential equations. Now we're solving logarithmic equations. And with this lesson, guys, whenever we talk about solving equations, all we're really doing is solving for x. Okay, we're solving for x. Before we did it with exponential, now we're doing with logarithmic. So there's a couple key concepts that I want to show you guys. The first concept is the same base. Okay, if you have a logarithmic equation where on one side you have log 7 and on the other side you have log 7, this is equivalent to having the same base. So what we can do is we can actually cancel these out and we can write our answer as x equals 4. So a lot of the times in these questions, guys, they're going to force you or they're going to bait you into doing this. They want you to get it as the same base so that you can cancel it out. So understanding the same base is a great technique in being able to solve these logarithmic equations. The other concept I want to show you is how do we isolate for x if we have the log that's glued to the x. So the way we do that is when we bring the log over the equal sign to the other side, it actually becomes an exponential equation, right? In the same way when we have an addition and we bring it to the other side, it becomes subtraction, or if we have a multiplication and we bring it to the other side, it becomes a division. In the same way, when we have a logarithmic equation and we bring it to the other side, it becomes an exponential. So this a, right, as the base becomes the new base of the exponential, and the b gets bumped up to the exponent. Okay, that's really interesting to know. It's a weird kind of operation because you don't usually do that, but this is what happens. The b gets bumped up to the exponent. So let's go through a couple questions to really see how this stuff works. So let's look at 2a, for example. Over here, we have a base of x, so when I bring it over, it's going to be 625 is equal to x to the 4. And then from here, what I like to do is I want to get rid of the x to the 4, so what I would do is I would say 625 to the power of 1 over 4 is equal to x to the 4 to the power of 1 over 4. And the reason I did this is I want to get rid of that exponent, so I'm just left with x. But whatever I do to the right side, I have to do to the left side. So 625 to the power of 1 over 4 is really just the same thing as saying the fourth root of 625, which is 5. So that's just putting it in your calculator and getting the answer. Okay, let's look at question D. What if the equation doesn't give you a base? So notice how here we had a base of x, but in this equation, we don't have a base at all. Whenever we don't have a base, we have to assume that it's base 10. So we have to assume base 10, okay? Now this is a common thing that a lot of students make mistakes on, is they just don't know to assume the base is 10. So anytime you see a question like this, guys, remember the base is 10. So what I'm going to do is I'm going to bring this 10 over to the other side and I'm going to solve. So I'll have 5x minus 2 is equal to 10, and then the 3 gets bumped up to the exponent, so it becomes 10 cubed. So you have 5x minus 2 equals 1,000. 5x equals 1,002. X is equal to 1,002 divided by 5. And there you have it. That's your answer. Okay, so very simple concept, guys. Same base, and when you bring it over, the logarithmic starts to change into an exponential. So let's go through some harder questions, like these questions in question 4. So let's look at these individually. Log x to the 27 is equal to 3 over 2. So I'm going to bring the x to the other side, and I'm going to get x is 3 over 2. But now, I want to get rid of that 3 over 2 because I want x to be by itself. So what am I going to do? I'm going to multiply this by 2 over 3, and whatever I do to the left side, I have to do to the right side. So when I do this, what ends up happening is the 3 over 2 and the 2 over 3 cancel each other out, so I'm just left with x. And then here, I have 27 to the 2 over 3. Now 27 to the 2 over 3 is the same thing as saying 27 to the 1/3 squared. And 27 to the 1/3 we know is 3. 3 squared, and 3 squared is 9. So this is how we would do the first one. Let's look at B. B says log x 5 is equal to 2. So 5 is equal to x squared. How do we solve this? All we got to do is square root both sides. So I can say root 5 is equal to x. And there you have it. That's your answer for B. Let's look at question C. Log 3, 3x plus 2 equals 3. I bring the 3 over to the other side, so I end up with 3x plus 2 is equal to 3 cubed. So here we have 3x plus 2 is equal to 27. 3x equals to 25. X equals 25 over 3. And there's your answer. Let's look at question D. Log x equals 4. So this is one of those questions. We don't have a base, so what do? We assume base 10. Now when I solve, x is equal to 10 to the power of 4, and 10 to the power of 4 is 10,000. Great. Let's look at question E. We have log, the base is 1 over 3 to the 27 equals x. So this one is a little bit interesting because the base is to the the base is 1 over 3. So over here, what I'm going to do is I'm going to say 27 is equal to 1 over 3 to the x. So now I have to actually get rid of the x's in the exponent. So what I'm going to do here is I'm going to log both sides. So I'm going to say log 27 is equal to x log 1 over 3. And the reason I did that is because I wanted to bring the exponent of x, I wanted to bring that to the front. Now I can just say log 27 over log 1 over 3 is equal to x. And some people might keep it like this, or you might be able to even plug it into your calculator. Log 27 divided by log 1 over 3, and you end up with negative 3 as x. Okay, and let's go to the last question, which is question F. You have log 1 over 2x is equal to negative 2. So here, same kind of question. You have x is equal to 1 over 2 to the power of negative 2. Now, for this, 1 over 2 to the power of negative 2 is the same thing as saying 2 over 1 to the power of 2, right? Because when I have 1 over 2 here, if I flip it, then what ends up happening is my exponent becomes, it changes its sign. And then it becomes a little easier because 2 over 1 squared is just going to be 4. So there's different ways that you can manipulate these equations, guys, but a lot of them comes down to these key concepts and mixing these key concepts with, your regular algebra. So let's look at question 7. 7 is a little interesting. This is a little bit more complicated because now we're adding different things together. So let's look at this. Over here we have the same base of log 7. And remember, we know that when we have the same base, what we can do is we can actually multiply these two together. Because the addition signals multiplication. And now what I'll do is I'll take that 7 and I'll bring it over to the other side. So we'll have x plus 1, x minus 5 equals 7 to the power of 1 because the 1 gets booted up to the exponent. Over here, I'm just foiling now, so x squared minus 5x plus x minus 5 equals 7. And then as you can see, a quadratic is forming as we go. So you'll get minus 4x, and then bring the 7 over, you get minus 12 equals 0. Now from here, we got a factor. So this is that extra step, which gives you x minus 7 and x plus 2, which now means x equals 6 from this guy, and x equals negative 2 from this side. So you see, this question was a little interesting. We had to use our knowledge from our previous logarithmic knowledge of when we add things, we have to multiply them together. But then we also figured out that, okay, because of this, we're going to form a quadratic. So when we get the quadratic, we have to factor it into its two roots, and then we get the two values from there. Let's look at B. Very similar type of question. Log 3, I'm going to combine this and the x. So I'll get log 3 x minus 2 times x. And notice how I'm putting them in this big bracket, right? Because I'm trying to stay neat with my process. So over here, if I bring the 3 over to the other side, I'll end up with x minus 2 times x is equal to 3 to the 1. This becomes x squared minus 2x is equal to 3 because I FOILed that out. And then from here, x squared minus 2x minus 3 equals 0. And what do we have here? Another quadratic. So we'll get x minus 3 and x plus 1, which gives me x equals 3 for this guy and x equals negative 1 for this guy, right? So these types of questions you got to also be familiar with. They like to put these in like thinking or application type questions. So it's good to know. Let's try question C. This one is interesting because we're subtracting. So notice how when we subtract for question C, the subtraction means division, right, from our logarithmic rules. So over here, I'm going to say it's log 6, but we have x over x minus 1 is equal to 1. So now with this, I can say x over x minus 1 is equal to 6 to the power of 1 because I brought the 6 over to the other side. And then I can say x is equal to 6 times x minus 1 because I brought the x minus 1 up, so it becomes multiplied. And then I have x is equal to 6x minus 6. And then from here, I can be 6 is equal to 5x. And then 6 over 5 is equal to x. So this is not a quadratic, but there was a division included in it. So you see how these types of questions, guys, you guys can easily get these questions on a test. I'm going to actually just write here. These are test type of questions because it combines multiple different logarithmic concepts. It combines the addition, the subtraction, the same base, the bringing it over to the other side, and it also includes the factoring component, right? So there's a lot of different concepts. And guys, the only way you're actually going to get good at this is if you practice. Like that's the truth. You have to do multiple problem sets of these for you to get a hang of it. So I want to go through this last question over here, question 10. And this question is a thinking problem, okay? So I'm just going to write here, this is a thinking problem. So let's look at this. What do I notice off the bat? I have A, and A, all the same base. So what can I do if it's all the same base? This first one, I'm going to have this as x plus 2 and x minus 1 because we're adding. So remember, the adding means we multiply. And this is going to be equal to log A of 8 minus 2x. But now, because I have the same base on the left and the right side, I can actually cancel these out. So now that I canceled it out, it's going to get a lot easier from here. I just FOIL it out. So x squared minus x plus 2x minus 2 is equal to 8 minus 2x. Then we're going to simplify. So x squared plus x minus 2 equals 8 minus 2x. I'm going to bring everything to the left side. So I'll get x squared, and then x plus 2x is x plus 3x. And then I bring the 8 over, x minus 10 equals 0. And then from here, we got the simple factoring. So x minus x plus 5 and x minus 2 would be the factors. So we got x equals negative 5. That's one of them. And then last but not least, x equals 2. So this one, very similar, same base. We know we can cancel out. It's actually really similar to the questions we were doing in question 7. But these are the types of questions I want you guys to be familiar with, okay? So if you found this video helpful, feel free to drop a like on the channel, subscribe, send it to a friend if you have friends who are struggling in this course. And everything you guys do for us, really definitely helps grow the channel. And I'm super appreciative for all of you guys who helped us get to 100 subs. So keep along, keep studying, keep along with the journey, and I'll see you guys in the next video.